Today we're going to be looking at how to solve quadratic equations, and we're going to learn to solve them 3 different ways. The factoring method we've already kind of touched on when we learned how to find excluded values of rational expressions, and in the rational expression we had a squared term. So we already looked at this method. These two might be new to you, they may not be. All of these, there's a specific form that the equations have to be in a specific process. So a quadratic equation is any squared expression or any squared equation. So as long as there's an x squared in there, it is considered to be a quadratic equation. However, it has to be the highest exponent. You can't have an x cubed and an x squared. X squared would be the highest exponent in our equation. Ax squared plus bx plus c, where a, b, and c are numbers. The only criteria is that the a number cannot be 0. Traditionally, we keep a greater than 1. We want it to be positive. So this is what we consider to be standard form. 2 of the 3 methods that we're going to talk about to solve these equations, they have to be in this form in order for us to solve the equation. Okay? We can also call these second-degree polynomial equations because the highest exponent is 2. So method 1, solve by factoring. I like solving these equations because for all of them there is a very specific step-by-step process. Step 1 to solve by the factoring method is you have to put the equation in standard form, which means you want all of your terms to be equal to 0. Okay, so wherever your ax squared term is, as long as it's positive, keep that there and move everything else to that side. Then you are going to factor. Factoring, remember, can be the GCF method, chart, box, difference of 2 squares, how you method here is, or how you factor here is dependent on what the polynomial looks like. Once you have your factors here, when you factor, you are looking for them to be linear factors. Remember, linear means you only have one x. So we are factoring with the purpose of getting that x squared down to x's. You will then set those individual factors equal to 0, and you will solve those equations to find your solutions. Okay, you can only use this method if you can factor. Okay, so I'm telling you to solve by the factoring method. Remember, step 1. One side has to equal 0. So since 5x squared is positive on the left, I'm going to subtract 45 to make the right side equal to 0. Step 2, I'm going to factor that equation. Well, this has 2 terms. They're not the difference of 2 squares, so if it can factor, the only thing I can do is take out a 5. When I take out a 5 from both terms, I'm left with x squared minus 9 equals 0. Remember, I said when you factor, you want to factor down to linear factors. This one is still quadratic, and that's because this polynomial is a difference of 2 squares. So I can factor that again into x plus 3 and x minus 3. Once I've factored completely, I'm going to set all of my factors equal to 0. 5 is a factor, x plus 3 is a factor, and x minus 3 is a factor. This one I can't solve, so that's not going to give me a solution for x, but this one I can solve by using inverse operations, and this one I can solve by using inverse operations. So the solution to this equation has 2 values of x equals -3 and x equals 3. Okay, next example, I still want you to solve by factoring. Again, one side has to equal 0. And remember, we want it in squared term plus variable term plus number equals 0. So when I subtract 1, it has to go behind the x. So 2x squared plus x minus 1 equals 0. Step 2, factor. This would be a box method or a guess and check method because my coefficient of x squared is bigger than 1. However, I know that 2x squared can only split up into 2x and x, and I know that the only factors of 1 are 1. My job is to figure out where does the plus and minus have to go. Okay, so the plus has to go here and the minus has to go here because when I multiply those middle terms I want a positive 1. So we're going to set those two factors then equal to 0 and solve for x. Again, these are now linear factors, so I can use my inverse operations. So x will equal 1/2 from this factor. Over here I can subtract 1, and x can equal -1. Last example, when we look at this equation, our x's are all singular right now, right? However, right now it's linear. Our linear process says, that we talked about earlier, that we have to distribute. When I distribute that, I get 16x squared minus 32x equals 8x minus 25. Once I complete my linear rule of distribution, now I can see that this equation is now quadratic because I get a product of an x squared. I still want to use factoring, so we're going to subtract 8x, and then we can add 25. So that will cancel, and I'll get 0 over here, and I get 16x squared minus 40x plus 25. Okay, again, this is a box method problem because it's 3 terms and the coefficient of my squared term is greater than 1. So we know it's going to factor into this. Let's do the quick box method over here. Just as a review, remember ax squared term goes here and c term goes there. And then we multiply those two terms together. 16 times 25 is 400. And I'm looking for two numbers that multiply to give me 400 and add to give me my b value, which in this equation is -40. Okay, those two numbers are going to be -20 and -20. Those slide into these boxes. Since they're both negative, we're going to have minus signs in both of our factors. The squared portion of that box can become an x and an x in each factor, and then I'm finding the GCF of each row in each column. So the GCF of 16 and 20 is 4, and the GCF of 20 and 25 is 5. As we go across the rows, we see it's the same thing. So both of my factors are 4x minus 5. If this happens and both factors are exactly the same, you do not have to solve both of them because they will both give you the exact same answer. So we can add 5 and then divide by 4. So x will equal 5 over 4. For my math lab, you can leave it in that form. You do not have to convert it to a decimal or an improper fraction, or sorry, a mixed number, as long as this fraction is reduced. Okay, so that's the factoring method. Make one side equal to 0, factor the polynomial completely, set your factors equal to 0, solve for the equation. Method number 2 is what we call the square root property. Now this is what my students in the past have told me is the easiest method. However, it can only be used if the equation has very specific terms. It is also one that is most commonly misused because of this little fellow right here. When you plug in your equation or you plug in a radical into your calculator, the radical is only going to give you the positive answer. However, we all know that there's more than one square root of a positive number. Okay? So the square root property says, if you can get your equation to look like the square term equaling numbers only, then we can take the square root of both sides, and our answer for x will be the positive and negative square root of that number. In order for you to use this equation, or this method, you can only have a squared term and a number. It does not have to equal 0. We want this to look like this. Ax squared equals our numbers. Okay? And then we will get rid of the a to have x squared equals numbers. Okay? So get your x squared by itself and take the square root of both sides. That is our goal. So identify our x squared here. We want to use the square root property. Our x squared is here. Okay, so we need to get rid of this subtraction of 21 by adding 21. So 3x squared equals 21. And then we can divide by 3 to get x squared by itself. Once we are here, we had to do all that work to get to step 1. Step 2 says you can take the square root of both sides. We do that because square rooting a square is the inverse. And by property, when you take the square root of both sides, you have to include that plus or minus. So our answer, the square root of x squared is x. The square root of 7 does not reduce. So we have two answers, positive or negative square root of 7. If this radical has perfect square factors in it, you must reduce. They will not accept an answer unless it is reduced. Example 2 here. This one could be a little confusing because sometimes people want to do this. But remember, I'm using the square root property. If I do that, I get x squared plus 5x, which is 10x, plus 25. Can I use the square root property if I have an another x term in there? No, I can't. So if you do this, you should know that you're doing something wrong because you can't use the square root property when you have an x squared and an x term. The rule says get x squared by itself. Well, doesn't this represent x? That is what's being squared. So I don't have to do anything to get x squared by itself. It's already there. So I can take the square root of that. The square root of x plus 5 squared. Remember, our square root cancels out a square, so I'm left with the expression x plus 5. By property, I am taking the positive and negative square root of negative 11. We talked about this in the last class. Anytime you have a radical that has a negative number on it, that negative comes out in front and becomes an I. So our answer is now imaginary. And now I want to solve for x. So I'm going to subtract 5. We cannot combine these two terms. A radical and a number don't combine. So we have plus or minus I radical 11 minus 5. Anytime we have a plus or minus there, we're going to put that in the middle of our two terms, so that minus 5 is going to go out in front. And our final answer for x looks like this. Remember that anytime you have a radical, you must reduce. That's not how you spell reduce. One more here. Okay, again, find your squared term. What is it that's being squared? Well, the expression 4x minus 1 is being squared. So here I need to subtract 6. So I have 4x minus 1 squared. My squared term is now alone on the left. And 22 minus 6 is 16. Now I can take the square root of both sides since my squared term is alone. Square root of 4x minus 1 squared cancels the square out. We're left with 4x minus 1. And by property, we're taking the plus or minus square root of 16, which is 4. Because this is a perfect square, technically I'm solving two separate equations here. I'm solving 4x minus 1 equals positive 4, and 4x minus 1 equals negative 4. If this was not a perfect square, you would just leave it in radical form and perform the plus 1 and divide by 4 to that radical and leave it in expression form. But here I can add 1 and divide by 4 to get a number solution, so x equals 5 over 4. I can do the same operations here. Answer is going to be a little different because it is now equal to a negative 4. Oops, sorry, that should be a 4. So x equals negative 3/4. Here's my two solutions. Okay, so to recap the square root property, number 1, we can only have an ax squared term and a number term. We can't have a bx term. We want to get our squared term by itself so that we can take the square root of both sides. Do not forget the plus or minus on your radical. Thank you. Method 3, Quadratic formula. You have all seen this before. This is the only method that you can use for every single type of quadratic equation, no matter if it has all three terms, ax squared, bx, or c. If it doesn't have those, you can still use it. Whatever term is missing, remember that number then would be replaced with a 0. Okay. Here's the process. Standard form is the form our equation has to be in, so it has to equal 0. The reason for that is because if we're plugging in a, b, and c in this formula, we have to know the true value of a, b, and c. If it doesn't equal 0, we don't know what that is. Okay? I'm really only going to do one example here because you really only need to see one. We're using the quadratic, change that to formula, which looks like this. X equals negative b plus or minus the square root of b squared minus 4ac. That entire sum and difference will be divided by 2a. Okay. Here it is. You need to know it. Make sure it's in your homework. I'm not going to give it to you on any in-class assignment. Okay. Make sure it's in standard form. So I need to subtract this 2x over. Remember, standard form is squared term plus or minus x term plus or minus number term. So when I move that over, I need to put it between x squared and 2 to make sure I have the correct a, b, and c value. Okay. I take a second here and I write out a is 1, b is negative 2, and c is positive 2. I do that so that when I'm then plugging it into the formula, I don't have to look at the equation and the x's and all that kind of stuff. So I'm using the formula to find x. Negative of b, that means I'm taking the negative of my b value, in this case it's negative 2. I'm going to add or subtract the square root of negative 2 squared minus 4 times 1 times c. That entire sum and difference is divided by 2 times a. And then we just follow our order of operations. Negative of b means negative 1 times negative 2, which gives us a positive 2. Plus or minus the square root, negative 2 squared is 4. Negative 4 times 1 times 2 gives me negative 8. All of that will divide by 2 times 1, which is 2. So x equals 2 plus or minus the square root of negative 4 over 2. Remember, anytime we have a negative number under a radical, we need to take that negative out and it becomes an I. And then we can reduce this. 2 plus or minus. The square root of 4 is 2. 2 times I is 2i over 2. And then we have two separate equations. 2 plus 2i over 2 and 2 minus 2i over 2. Remember, my math lab will require you to separate those. So you have 2 over 2 plus 2i over 2, which equals 1 plus I. And then we have 2 over 2 minus 2i over 2, which equals 1 minus I. Here are our two solutions. They are not real numbers. They are imaginary numbers. If any of you remember quadratic equations, when you graph them, they make a parabola. Okay, where your parabola crosses your x-axis is your solution. So when you have a real number solution, it means it crosses the x-intercept. This would mean my parabola is above my x-axis and will never touch it. So I have imaginary solutions, but I do not have real number solutions. Okay, look at your email for your assignments. I will see you soon.